This example illustrates the conservation of energy and also explains how energy transfer occurs between the plates of the capacitor and the, and the battery that's connected to the capacitor. So here is the statement of the problem. So you have two plates in a capacitor, each having an area A and a separation distance x, and they are connected to a battery with voltage V. While the plates are still connected to the battery, the plates are pulled apart until they are separated by a distance 3x. In other words, the distance is tripled between the plates. So let's calculate what are the initial and final energies stored in the capacitor. To do this part, it's advantageous to use the energy stored in the capacitor given in this form. So since we know what the capacitance is and what the voltage is, let's just go ahead and use this. And also, since after pulling the plate, V is preserved, so V doesn't change the problem. Increasing the plate separation, of course, decreases the capacitance, so the initial and final energies can simply be calculated by knowing the initial and final capacitances. So that turns out to be given here. This is the change in the energy stored in the capacitor is half V remains constant, change in the capacitance, and area remains constant. The only thing that changes is the distance. So the final distance is 3x, so it's 1 over 3x minus the 1 over the initial distance. So that's the energy, which turns out to be minus 2/3 of the initial energy. So in other words, there is a loss in the energy stored between the plates of the capacitor. There's a loss in the potential energy. This might seem a little bit odd since we've done work in pulling the plates of the capacitor apart. So how come the change in energy is negative? So let's proceed to calculate how much work is required to pull the plates apart. So we're just going to use the force needed to pull one charge away from the other charge. So here's how that works. So if you have a force F and you move a distance dl, that's the work done. So in this case, there is a force on one plate due to the charge on the other plate, or due to the electric field set up by the other plate, and you're moving a distance from x to a distance 3x, and so the work can be written as the electric field times dl is the work done per unit charge multiplied by the charge q on one plate will give you the total work. And the electric field, of course, is equal to the potential difference divided by the distance, and in this case we have to consider only half the potential difference, since we can only count the field produced by one plate. The other plate contributes the charge. We cannot count it twice. Of course, the capacitor equation is always true. Q of t equals C times the voltage. So the work done to pull the plates apart is Q times E times dl, with the dl, the distance going from x to 3x, and plug in the numbers. So here you have for the electric field is just the expression given here, V by 2L, and the other quantity is epsilon 0 A V by L come from the expression for the capacitance times the voltage. So Q equals C times V, So we substituted that here. So you simplify all of this and you get the work done is 1/3 of epsilon 0 AV squared by x. So the work done is positive in contrast to the previous case where it was negative. So potential energy decreased, change in the potential energy is negative. So what is the answer to this puzzle? So we've done positive work and yet obtained negative potential energy change. So the answer to the puzzle is here. How much energy is exchanged with the battery? So the energy exchange with the battery, of course, the energy conservation theorem has to hold good. So you have the total work done equals the change in the potential energy of the capacitor plus the potential energy of the battery. And therefore, you can calculate what the change in the potential energy of the battery is. That's just W minus the change in the potential energy of the capacitor. And this quantity itself is negative. So the two negatives go away and you end up with a positive quantity. So it's the battery that is responsible for the work done, and the potential energy actually uh, decreases between the capacitor plates. That is, the energy stored in the electric field between the capacitor plates is lower in the second case.